Hello students, welcome to CBSE Science series. Today we are going to learn about forces between multiple charges. We already studied about Coulomb's law in vector form. I uploaded one video based on these topics. If you didn't watch that video, you please watch that video and subscribe my channel. The Coulomb's law tells the attractive repulsive force between two stationary point charges, that is F is equal to k q1 q2 by r square. This is for only two stationary point charges. If there are n number of charges, what is the force on the charge q1 due to the presence of q2, q3 up to n charges? How can we calculate that? We can calculate that by using the superposition principle. Superposition principle is based on the property of the attractive repulsive force between two charges not affected by the presence of other charges. How can we use the superposition principle for n number of charges? For that, first you consider three charges. Name them as Q1, Q2, Q3. These are the three charges, and the position vector for these three charges are R1, R2, R3 from the origin. And we are going to calculate the force on the charge Q1 due to charge Q2 and charge Q3. Consider the force on the charge Q1 due to Q2 is F12, and the force on the charge Q1 due to Q3 is F13. And according to the Coulomb's law, F12 equal to F12 is 1 by 4 pi epsilon naught Q1 Q2 by R12 square R12 cap. Here R12 cap is the unit vector which is used to specify the direction of the force. Here the force is repulsive force because all these charges are like charges. So the repulsive force direction will be like this. And F13 becomes the force on the charge Q1 due to Q3 becomes 1 by 4 pi epsilon naught Q1 Q3 by R13 square R13 cap. So this is also unit vector. R13 cap is the unit vector which is showing the direction of the force on the charge Q1 due to Q3. Now look at the direction of these two forces. These two forces are acting at a common point. According to the parallelogram law of addition, when two vectors are acting at a common point, the resultant vector will be along the diagonal of these two vectors. So the resultant force of the Q1 charge is F1, which is the addition of these two forces F12 plus F13. Now the total force on the charge Q1 is F1 is equal to F12 plus F13, which is equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 square R12 cap plus 1 by 4 pi epsilon naught Q1 Q3 by R13 square R13 cap. Similarly, if there are n charges, the total force on the charge Q1 due to the other charges becomes like this. In this expression, the Q1 divided by 4 pi epsilon naught is common. So if you take that out, we can write this expression as summation I is equal to 2 to n for n number of charges. Summation I is equal to 2 to n qi divided by r1 I square r1 I cap. So this vector addition is based on the parallelogram law of addition of the vectors. So this is what the superposition law. So by using the superposition principle, we can calculate the total force on one charge due to the presence of other charge. That is, when a number of charges are interacting, the total force on given charge is the vector sum of the forces exerted on it due to all other charges. The force between two charges is not affected by the presence of the other charges. This is what the principle of superposition. Thank you.